Yeah, good evening. Last documents. In the last session, we discussed about the 3 ways to create RDD. What can be done with RDD, the lazy evaluation and the data flow execution style. So today we do some practical stuff. Just see the basic Spark lab. So before getting into the Databricks, do the practice of the Spark with Google Colab. How to set up Spark in the Google Colab first place. Then the last session theory, what are the 3 ways to create RDDs? So those things we will discuss. Okay. All of you getting my screen?
Yes.
Yes, sir.
Yeah. Okay. I'm starting Google Colab. So first connecting with runtime. So these are the 3 steps you need to follow. First, you need to install findspark and findspark. This is generally findspark is not required. Only to set up this into the Google Colab, this is required. First step is pardon?
Sorry. So we don't need to install the application, so we have to do it on Google Colab.
No need. Directly in the Google Colab, you can set up this. So once you step into the Databricks, then the Databricks you have cluster provision. Okay, there you can create clusters and then you can practice. This is before Databricks, the PySpark practice.
Sir, we will practice Databricks also in future.
Anything. Data set
In
means
in
not
this
data,
class, sir.
data frames. Okay. In Spark, you have data frame concept. First, initially, we are working with RDDs. Next, we go to the data frames. So after completion of this, then we go to the Databricks. Okay.
Okay, sir.
So to here, our specialization is Azure Databricks. This is first step. Next, find spot init object. Come to the next cell, just keep this. Then third step, Spark session object. Once this practical stuff is completed, then I will explain about Spark session. Okay. Sorry. This is third step. But if it is Databricks, whenever you start Databricks cluster, all these things will be ready with you. No need to create all these things. You are doing this practice in the Google Colab. That's why you need to set up all these things.
Okay, only for the
Okay.
online compiler like Google Colab, what we are using, we have to do this, right? So first,
Google Colab or any local machine or any Linux machine you want to set up, these steps you need to follow. Suppose you are working with the Synapse Spark or Databricks Spark, then no need. When our cluster is started, automatically these things will be ready.
so do we need to understand, sir, what is import find spark or just copy paste?
Pardon?
Do we need to understand, sir, import find spark? What is a find
So
spark?
first, nothing to worry.
Okay,
Find Spark was here. What happened in the first statement?
pip install, sir.
Just installed.
Yeah.
Where it is a Spark setup got installed, this will find that location.
Okay, where it's being installed.
Then to work with the Spark objects, you need Spark session object.
Okay.
That's it, simple.
Then we'll,
Okay.
okay.
So here we have our in Spark, what are the data objects? RDDs. Okay. To work with RDDs, we have special API called RDD API. To work with RDD API, we need Spark context object. Which is simply short name, SC. I'm creating that SC equal to already Spark session object previously created. The Spark dot Spark text. Now check this. I'm going to run this. Okay, SC created. Just run this SC only. Current version of the Spark is 3.5 something. 3.5.1, which is latest version it has taken. Okay. Now, what are the three ways we discussed to create RDD? Come on, try to recall. Way one.
To create another RDD.
When you parallelize local object, right?
Ah.
Local object. Let's take one X. X is a list. 10, 20, 30, 40, 50, and 60. So here X is local. Is a list object which is local object. This is not RDD. I want to make this as RDD. Let's say RDD equal to SC dot already SC object previously created. Parallelize. Parallelize of X. Observe here the type of RDD. Now it is an RDD. PySpark.RDD.RDD. This is object. Okay. So actually all this entire Spark is developed by Java. Okay. So Java, based on the Java Scala created. By using Scala language, the Spark is developed. After that, they developed an API for the Python. The Python API for the Spark is called PySpark. Got it. Now the type of previous object is RDD. Just to change the name. Here I am saying that capital X. Small x is Python list. Capital X is RDD.
RDD.
Now X is RDD. X dot collect. The same data you are collecting. So you are performing X here. Collect is an action. Whenever you perform action, then only the data flow will be executed. Of course, we have only one RDD. That's why there is no question of data flow. Okay. So this is way number one. And one more way, which is way two. when you read data from file using
Spark context.
RDD will be created. Let's say R1 equal to, let's say data equal to sc.textFile of em.txt. Let me give the full path. First, we need to upload this file into Colab, then do this statement for in your practice. Or take any file. Just I am uploading some sample file here. Let's say emp1.txt. This is our file. Look at the data. This is my data. I have totally around 13 records. Okay. It is a delimited file. Whatever it may be, it doesn't matter for the Spark context. Simply our statement is this one. Do this. Now data is created. What is the type of data? That is not local. That is RDD. Now data is also RDD. This is second way to create your RDDs. Now simply say data.collect. You will see all the data. It returns a local object. I think file path is not EMP.
EMP1.
It's EMP1. So runtime, suppose if I say this one, if I run it, it did not show any syntax error because RDD is not executed. When RDDs are loaded into the RAM, when these RDD statements will be run?
Action is triggered.
When you perform action. But when after performing action of our data.collect, it is trying to load this file into the RAM, but emp.txt file is not available. That's why it has shown error. What is the file name we uploaded? EMP1.
EMP1.
Okay. I'm rerunning this. Now run your data.collect. So it returns a local object. So each element is a string. Each line is treated as one line, one record, one element. Like, so I have 13 records, 13 lines in the file. That's why 13 elements in the list. Got it.
It is RDD, sir.
This is not RDD. Collect result is into local. Data
Okay.
is RDD. But when you perform the collect, it returns local object.
Okay, sir.
For example, if I say result is equal to, this is my statement. What is the type of RDD? Type of data?
Result.
That is RDD, right?
Type of data
Yeah.
RDD.
Type of data is RDD. What about type of result?
List.
Okay. That means always collect returns a local object.
Yes, sir.
This is the second way. Come to the third way. What is third way?
Creating RDD using transformations.
Yes, when you perform a transformation, one more RDD will be created. When you perform transformation. On existed RDD. A new RDD will be created. Let's do this. Again, I am coming from the scratch. X equal to 10, 20, 30, 40, 50, 60. What is type of X?
List.
List. That means local. Come on, make this as RDD.
sc.parallelize of x.
Parallelize.
Of X.
sc.parallelize. Parallelize of input X. Okay. Now R1 is RDD. Now I am saying R2. R1 dot map. Lambda X. X plus 100. So here X represents each element. Okay. So automatically loop will be performed internal. Suppose in the first iteration, what is the X value? 10. For the 10, 100 is added. Next iteration, 20. 20 plus 10, 120. Like this, 130, 140 up to 160. One more transformation I am performing. R3 equal to R2 dot filter. One more. Lambda X. X greater than 130. Just check with these examples. Once this is run, answer few questions. What is the type of X?
List.
Type of R1.
RDD.
RDD.
R1 dot collect. You will get a local object.
Local object.
Next type of R2.
RDD.
RDD.
Derived. How R2 is derived? Transformation on R1.
R1.
So that R2 is also RD. Got it. Check the result. What it is saying? PySpark.rdd dot pipeline RDD. What is the meaning of pipeline RDD?
Transformed RDD.
Yes, transformed RDD. That means this RDD is derived from one other from other RDD, right? That is the understanding. Whatever it may be, finally that is also RDD. Come on. Next question. Type of R3. First R2 data check it. R2 dot collect. When I say collect, from where the execution will be started? First R1.
R1.
R2. The result will be collected. What is the data of it? 110, 120, 130, like this. For each element, 100 is added. Okay. Similarly, type of R3. This is also RDD. Check here, it is showing as pipeline RDD. R3 dot collect. What is the expression I have given?
Greater than
Greater
130.
than 130.
Greater than 130. That is 140, 150, 160, these values will. Got it? This is third way to create our RDDs. Finally, three ways we have. Okay. In last class, we discussed all these three ways theoretically. Now this is practical part. Okay. So one more statement we have on RDD. We can perform two operations. What are those? We can perform two operations. What are those? Number one, transformation. Number two, what about this map? Here in this example, you have seen map. Map is
Transformation.
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 Transformation. Okay, I apply something called sort.
Transformation.
Transformation.
Reduce by key.
reduceByKey is also transformation.
Transformation. Reduce.
Action.
Reduce action. Reduce by key is transformation. Later I will explain what is the difference between all these things in coming sessions. Come on, tell me, collect.
Action.
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 Some.
Action.
Transformation.
Action.
Action.
All these are actions. Okay. Let me keep into the notes.
Hello.
Sir, only these exist or these are just the examples?
Once again, please, your voice low.
Only these exist, sir, or these are just the examples of transformational actions?
Oh, many transformations are here.
Oh,
Okay. This just up to now we used only two things, map and filter.
okay, sir.
I keep the previous text here. Come on, come back. One scenario we'll see. You can understand many things here. First, before this, okay. Is there any file? Wait. For unstructured data, I'm able to check. I need one unstructured data. Let's look at comment. Think that these are the reviews by the students about my class. So look at the first student. He is giving a review like the class is good. What about second student?
The same
Boring,
So third student, lagging.
lagging,
Excellent. The fourth, fifth, worst. Teaching is worst. Practicing is boring. Learning is
learning
worst.
is worst,
Is good.
class is
Teaching
good,
is hot. Food
food
is
is
not
not
enough.
enough.
Means you can understand something here. A few comments are about class, few comments are about resources, whatever it may be. Okay. Finally, there are some student comments. Now, what I wanted to do is word count. I want. Look at the word class. How many times class word is there?
Six times.
Six times.
Good.
2 times.
One,
Worst. Three.
3.
three times.
Like this. Okay. So in this way, like about each word, first you tell me this data is structured or unstructured.
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 What is your definition for the unstructured? Why you call it as unstructured?
Because it's not in a column.
Yeah, column and row wise, no? Then we can
Not
consider the
arranged.
There is no fixed pattern. That is the reason. Let's consider this employee data. Where is employee? Let's talk about this data. Structured or unstructured?
Structured.
Structured.
So in the first row, what is the second field? In the first
ID
row, what is
name.
the second field?
Name only.
Amar.
Last row, what is the second field?
Name.
Kash.
In every row, name is second field. ID is first one. Salary is third one. Gender is fourth one. Department number is fifth one. Right?
Yes.
In every row. Whatever the pattern you have for the first row, same pattern, same structure for each and every row. That's why this data is called structure.
sorted.
Okay. But here, you write your comment in 3 words and he is writing comment, other person may be writing comment in 4 words. There is no fixed pattern, right?
Yes.
Okay. That's why this data is unstructured. So first of all, the base practice, I need word count. How many words are there? Let's consider this. I keep in the notes. Where is the comment? input file, comment.txt. Below is the data. This is data. Now task is like this. Find frequency of each word. Frequency means here occurrences, number of occurrences. Example output, the word class, how many times? 6 times. The word host,
3.
how many times?
3.
3 times. Like this. Okay. In this way, this is expected out. For this, already first time I am uploading this file. What is the file? Comment.txt. Come on. First I want to read the data. Data equal to. What is the statement you have used previously?
sc.text
Sc. Dot.
Text.
file
Give the path.
Content.
The file name.
comment.txt.
Comment.txt. That's it. Let's run it first. So before this, I will keep some notes. Come on, tell me the statement to read the data.
Data
Sc dot. How many partitions will be?
2 partitions.
What is the type of data?
RDD.
RDD. How many partitions will be there?
2 default.
2.
Default how many?
2.
2 partitions.
2.
No, 2 partitions.
2
By default, it will be 2.
Default 2 partitions. Okay, how to make sure? Data dot get num
partition.
So, sir, we are calculating here how many number of partitions are there.
yes. How many now?
2.
So,
2 partitions. Okay, you can control it also. Later we will see how to control it. Okay, you can increase number of partitions, you can decrease number of partitions. First you tell me this is small data or big data?
Small.
Small data.
Small data.
This small data parallelism is not required, right?
Yes.
Data
Yes,
volume
sir.
is very small. No need of parallelism. Then you can set it to one single partition. Okay, suppose data is very big, maybe 1 lakh reviews or 2 lakh reviews like that you have. Suppose think that business is not mine, business is Amazon's. Amazon online. How many reviews daily?
Lakhs of.
Billions of reviews per day, right?
Relax. Yeah.
Okay.
Not lakhs, into billions. The number of reviews in the worldwide of Amazon.
So,
So
per
definitely
each product we are seeing so a complete website.
complete all products.
Okay. Yes.
Amazon is selling more than 1,000 categories of the products.
Yes, sir.
Under each category, again thousands of products.
Yes, sir.
That means Amazon's customer count is greater than their Amazon product count is greater than their customer count on that way.
Yes.
Understand? So you cannot guess how many reviews that they will get per day. Okay. So such kind of data you cannot deal with in a normal local machines. The biggest Spark clusters are required for that. So they are using Databricks with AWS. Okay.
Yes, sir.
Yeah, come back to this one. What is our task? Remind our task. Just where is
Word
it?
Yes, we
Found
wanted to
the
know how
frequency.
many times frequent.
Now data.collect, just check what is a sample. Each line has element in the list.
Yes.
Okay. So in the next transformation, what I am doing is I want to take each line and I want to split that into words. Words equal to input data dot map. Whenever you wanted to do something on each and every element, map is the transformation. Understand?
Yes.
Whenever, remember once again, whenever you wanted to do some operation on each element. Okay. So here also technical definition, you just look into this one. Once again. Previously it has shown something. So that means some function or some operation you want to run on each element, then map is the transformation. To work with each element, lambda x. Any name you can give, lambda y, lambda z, anything you can say. My favorite name is x. Lambda x. What I wanted to do each line, I want to split that into words. X dot
Split.
splitting based on space.
Okay.
Okay, default delimiter is space. But here some words are in uppercase, some words are in lowercase. If it is the case, it is highlighting at the time of finding word count. For uppercase separate count you will get, for lowercase separate count you will get. That's why before splitting, what I am doing,
Lower.
converting into lower.
Lower.
Even though if there are any uppercase letters, that will be converted into lower, and then I am splitting. Okay. So now splitting is done. Now check the data of these words. Words is RDD, because data is RDD. On RDD you perform a transformation so that words will also be RDD. If I say collect, what is the data type?
List.
Previously list of string, now list of list you will get. Check it. High level, that is a list. Again, each element is list of list file. Okay. Now I am doing small change. Observe what is happening. Instead of using flat map, I am using flat. Now tell me what happens.
Okay, it's only list.
Previously, what was that? List of list.
List of list.
What is this?
It's only list.
Just list.
Just list.
That means what is the functionality of flat map? Converting double dimension into
Single.
list of list means double dimension, right?
Yes.
List of list is a double dimension. Converting list of list, that means double dimension into single dimension. Suppose input is a triple dimension. Input is triple dimension. If I apply flat map, you will get double dimension.
Oh, for the triple
Input is n dimension.
Yes.
Input is n dimension, sir, n. Now if I apply flat map, n minus 1. Understood this?
Yes.
So this is flat
sir.
map. Now list each element is a word now. Come on, what is the task?
We need to count a
Each
word.
how many times, right?
Yes.
That means the grouping aggregation you are going to perform. To perform the grouping aggregation, reduce by key is the transformation. But for reduce by key, input should be pair RDD. Then what is a pair RDD? Here pair is a tuple of key and pair. Pair is a tuple of key and value. Each element should be in this form. Okay. That means class is a key, one is the value. Ease is the key, one is the value. Good is the key, one is the value. Why one is the value? Because I am going to perform count. Whenever I want count, value should be 1 here. Let's make it pair equal to. What is the input?
Words.
Words. Okay. Words dot map. Lambda x. Here x is each word. I'm transforming that as a tuple. Key value. A tuple of key and value. What is a key? Word. Word is in x. What about value? 1. Okay. Now what is the shape of it? Just check it. Pair dot take 5. Only 5 will take means first 5 it is taking. Collect means all the data it will take it. Take is also action. It takes only first 5. Just check this. What is the difference between previous output and this output? What is the difference between previous output and this output? Previously, each element is what?
List.
List.
Only
One
in the
element.
list is what? Word is each element, right?
Yeah.
Yes.
And now each element is what?
Pair.
Each
Pair.
element is a
Pair.
pair. Pair is a full of key value. But which is key, which is value? Always first one is key here. Always first one is key. Second one is
Value.
Understood my point? Up to now your journey is what, sir? First we did data. Data to words. Words to pair.
Pair.
But this is not our final output. Our final output expectation is this one. Now pair ready. Once pair ready, you will be using by just simply I am going to apply the reduce by key. Check what happens. Word count equal to pair is the input dot reduce by key. Here expression is different. Lambda x comma y colon x plus 1. WCNT dot column. What is the expression meaning? I will explain later. Just observe the output, what happens. Now tell me your comment. Look at the word worst. How many times?
3 times.
3 times. Lagging 1 time. It will go top. Class how many times?
6 times.
6 times. Okay. Total result is correct or not?
Yes.
Okay. How exactly this reduce by key works? A small talk on this. Let me connect with whiteboard. Whiteboard in. One minute, sir. Go with this. Let's take some sample pair here. It's not working. Whiteboard. Suppose a sample pair. A1. Next one is what is B? The value is 1. Next word is again A. Value 1. B 1. A 1. Think that you have 5 elements. Got it. How many partitions you have? 2 partitions. Okay, forget about partitions. Later we will discuss about it. When you apply the reduce by key, what happens internally? This thing I want. What is our complete statement? Pair dot reduce by key. Lambda x comma y colon something you said called x plus. Don't read that a goes to x and 1 goes to y. No. Okay. So in the first iteration, what happens is the first one goes to x. Okay. Now x value 1, y value 1. What is the expression? X plus y. X plus y, how much? 1 plus 1, 2. Whatever the result you got it. Again, this goes to x. The next value is coming into 1. So x value how much now? 2. Y value 1. Now x plus y means 3. This result again coming into x. Now x value is 3. Y value. This one. Now x plus 1. 4.
4.
This result again goes to x. Now y value.
1.
The next value is coming into y. Now 4 plus 1.
5.
Now after this all elements completed, then close. The result is this is result. But here I have 2 keys, right? If it is 2 keys, how it works, we will see. I have A is 1 key, B is 1 key. What happens internally, we need to understand. Let me close only this part. Step 1. Internally, what happens is grouping will happen. A is key. List of all A's. How many? 1 comma 1 and third one. Okay, this is one thing. Similarly, B. What are the values of B? How many B's?
4.
2.
1, 2.
Got it.
Okay.
Now this data is divided into 2 groups. Group 1 is A, group 2 is B. These 2 groups process will be done parallel. 1 minute, let me take water.
Just go back on your left-hand side. Yes, on the left hand.
Total 5
Just go
okay.
straight.
But
Just go
A,
straight. On left.
total 5 okay, but A how many? A 3, B 2. So before that computation, before that aggregation, first grouping will happen. Again, look at A group separately. And this is stuck in whiteboard stuff. Wait. Your expression lambda x comma y colon x plus y you said. X, y, x plus 1. First one goes to x. This one goes to y. What is x plus y?
2.
2. Again, this 2 goes to x. This one goes to y. So here I have 2, here I have 1. What is the result now? X plus y is 3. So final result is what? A 3 times. Here what is the result? First one x. Second one into y. X plus y. All elements completed. So that here what is the result? B 2 times. Again, these two results are collected. Finally, what is the result? List of A 3 times, B 2 times. The word A available for 3 times, the word B available for 2 times. This is the final result. Understood? Let me keep here.
Sir, reduce by key automatically does grouping, sir.
Yes. What are the step 1 to up to step 2? This is step 1. This part is step 2. This computation is step 2. Step 1 and step 2 automatically internally this process will happen. Okay.
Okay, sir.
Just wait. Now I got word count. Once again check the data. WC and D. Dot. Right. Yeah. Come on, sir. I'm taking some sentiment words, sir. So in this given data, what are the which words are related with sentiment? So this is output. From this output, which words are about sentiment?
Good, boring,
Boring. Boring, 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 boring.
lagging.
Lagging, excellent, worst. Okay, these are the things. Okay, I'm giving wantedly some sentiments here. That too, I'm classifying these things as positives and negatives. What are the positives here?
Good,
Good,
excellent,
excellent, amazing, etc. What about the negative sentiments, negative words?
lagging, Lagging.
lagging,
First.
Worst.
worst, the boring. Okay. Such kind, some more words. Okay. So these are the three words. I am taking help of these three things. I want to filter only sentiment words. Remaining things, I don't know. Only sentiment related. Sentiments equal to. What is the previous input? WCN dot filter. Here, my filter function I am giving. What is that my filter? I am creating a function. My filter. I am passing input as tuple. The pair is my input. In the pair, separate the word. Within the pair, where is the word? First one, right? Pair of 0. Find whether this word available in positives or negatives. If word in positives plus negatives. What is the positives data type? List. Negatives data type list. List plus list, what happens?
List will form.
New list will form. Okay, if you confuse, keep it this like this. Send for sentiment. If word in send. If word in send. That can be positive sentiment or that can be negative sentiment. This is the condition I am giving. Or simply, I am keeping only condition part. Okay. This thing I am writing. Just check what happens. Keep this in the next cell. Later we will use it. This is just my function. I am going to pass one tuple here. My filter. The word is, the pair is like this. The tuple is like this. Class as key. 6 as value. What I will get, true or false? I got false. False, sir. Because the word class is not available in positives, not available in.
Any of the list. Any of the list.
That's why false. Suppose I am passing something good. Good is sentiment related word. That's why true. Suppose I am passing worst. Worst is sentiment related. Suppose something I am saying bad, but bad we did not mention. Let me keep that bad also in the negatives. I'm rerunning this. Let's pass like bad here. What is the expected result? Understood.
Sir, what is the purpose of 6? What is the purpose of 6, sir?
Let's say 60. After every tuple, what is there? Word and then count. Got it? I am passing that entire tuple. Then it is taking the first one. Whether this word is available in the sentiment list or not, it is taking. Understand?
Okay, sir.
Your tuple contains two things, word and count. That's why I'm passing entire tuple as input for this function. I prepared my custom function over here. Now I'm going to apply the filter. Sentiments equal What is the previous output? W cnt dot
Filter.
lambda x.
Lambda.
What? X is what? In the WCNT, each element is
Okay.
what?
K.
Yes, sir.
Y.
In the WCNT. Look the data. In the WCNT, what is each element?
Tuple.
Tuple.
Each element is a tuple. Each element is a tuple. Pass that tuple to
My
what is the function? My filter, right? My filter of x. So for which element the given condition is true, only those elements will be taken. Now check the data of this. Sentiments dot
color.
what is the output now? Tell me your understanding by seeing this output. What is the difference between previous output and this output?
Data is filtered based on the
Previous
positive
output contains sentiment votes and non-sentiment votes also, right? But now it contains only
sentiment.
sentiment votes only. Good is a sentiment word, boring is about sentiment, lagging sentiment, excellent sentiment, worst sentiment. Everything is about sentiment. Understand this? Okay. Look at the good. That is a positive or negative?
Positive.
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 Boring.
Negative.
Negative. Lagging.
Negative.
Excellent.
Positive.
Positive.
Positive. Worst.
Negative.
I
Negative.
want to classify them. I want to classify them. Now I am creating one more function. Define sentiment. Input this tuple. Okay, input is about tuple. First separate the word. If T is a tuple, first one is word, right? T of 0.
0.
T of 0. Next.
Written
Whether it is
word is
positive sentiment or negative sentiment.
positive.
Good is positive. How you know? All positive words we kept in one list. All negative words we kept in another list, right? With the help of these two things, I am going to plan. If word in positives. Now, if it is true, what is the meaning? If that word is available in the positives list, what is the meaning? Sentiment is equal to
Positive.
Positive sentiment.
positive. Else, if, which is elif, if that word in
Negatives.
negatives. Of course, no chance. If the word is not available, only you are taking only positive words. If the word is not available in positives, means definitely that is
Negative.
that's why
Else.
else. Send equal to
Negative.
negative. Okay. Now good will be transformed as positive.
Positive.
Boring.
Negative.
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 Positive. Worst.
Positive.
Positive.
Negative.
Negative.
That's why I want to transform. Now finally what I'm going to return is return T value. What about value? Same value I'm taking T of 1. Whatever the value here, the same value I want to take. In the place of key, I am keeping send. Just check with sir. If good comma is passed, what happens? Tell me. If good comma 2 is passed, what happens? Tell me.
Positive.
Positive comma 2.
Positive will return.
What is the word value?
Good.
Good. Condition true or false?
True.
True.
So that what is the value of sent?
Positive.
Positive.
Positive. So that what will be written?
Positive.
Positive and 1.
And
Two.
2.
Value?
2.
2.
2.
Okay. That's why I'm writing like this. Okay. This is my custom function. This custom function I want to apply on my transformation. What is the previous RDD? Sentiments. Okay. Now, sent equal to sentiments 2 equal to final sentiment. This is final sentiment equal to input is sentiments dot map lambda x. X is what? What is x? Each element.
Each.
Each element is what? Each element is
tuple.
what? Pair.
Tuple.
Tuple. That tuple I am passing into previous function. What is the previous function name? Sentiment. Sentiment of x. Now check final sentiment dot color. Check the data, please. What is your understanding? Every word is turned into two categories: positive,
Negative.
negative. Now positive 2, positive 1. Total how many positives?
3.
3 positives. What is the score of negative? 3 and
6.
6. Total 6. I want that result. Again, report, sentiment report or sentiment score equal to what is the input? Final
Sentiment.
Sentiment.
dot
Reduce by key.
Key.
lambda x
X.
comma colon
X plus
X plus Y.
x plus 1. Understand? Now how many rows you will get? How many pairs you will get? 2. Because I have only 2 groups: positive, negative.
Negative.
Get the data. Sentiment score dot
Collect.
what is your understanding now? Total number of positives,
3.
number of negatives,
6.
6. What about quality of the performance?
Bed.
Very bad. Understand? Performance is bad because ratio is 50%, right? Not even 50%. Total, what is the total sentiments?
9.
Total sentiment score is what?
9.
How to say? I want to find out total sentiment score. This 3 plus 6 total 9. How to get it? First scores equal to previous RDD
Sentiment score.
and score dot map. X.
X.
X is a tuple. From the take set.
1.
Is a tuple I am taking second one. Right? What about scores now? Scores dot collect. Scores dot collect. What are those? 3 from the positive tuple, 6 from the negative tuple. Right? For this, I'm applying dot sum. TOT. Now what about TOT value?
9.
What is this
Okay.
sum? What is this sum? Transformation or action?
Action.
Sum is action. The result is into local. Understand the point, sir? Now, I want occupancy. What is the occupancy of the positive? What is the occupancy of negative? I want. Got it? Positive occupancy and negative occupancy. This thing I want. This time, I don't want to disturb the key. I just want to apply some operation on value path. Whenever you wanted to do something on the value path, there is another transformation called mapValues. Understand? Up to now, I have seen map. Understand? But this time, I don't want to disturb this positive. Positive should be as positive only. Negative should be as negative only. But I want to turn this as 3 by 9 into 100. I want to turn this as 6 by 9 into 100. Understood? I'm going to do that now. Just observe. One more transformation you can see. Let's say sentiment occupancy equal to, what is the input? Sentiment score. I'm taking this. Sentiment score, sorry, not here. Let me keep this. Sentiment score dot map values. So whenever you are applying map values means input is a pair, but you are working on value path. Lambda x. Here x represents what? What is x here?
Value.
Value of the tuple. Understand? Value part of the tuple. That means second one of the tuple. So second one is already a sentiment score, that x divided by total into 100. So suppose what is the first one? What is the first tuple in the sentiment score? Positive, right? How many positives?
3.
3 positives. Now x is 3. 3 divided by 9. Total is 9. 3 divided by 9 into 100. Similarly, in the second iteration, in the place of x, what is applied? 6 is applied. Negative value. 6 divided by 100. This is for the second tuple. Now finally check it. Sentiment occupancy dot color. Still I will get 2 pairs. 33.33, 66.66. Let's turn this easily into some integer part. I don't want to decimals. Applying the integer part. Now check it. Now positive 33.
Negative 66.
66. Major occupancy by?
Negative.
Negative.
What is your final understanding? What is your final understanding by seeing this report? You think that you are a management. You are a person of management. Most of students or most of customers are not satisfied. Understand? So you need to think about like whether to change the faculty or not. So always management takes the decision by seeing these scores. Whatever the work we did, simply this is a project of sentiment analysis. All of you clear?
Yes, sir.
Yes, sir. Yes, sir.
So many transformations you have seen. What are all the different transformations you have seen?
Map.
Occupancy of sentiment. What transformation you have seen here? One is map transformation.
Filter.
And also I have seen, especially in this example and in this sentiment example only.
Reduce.
Flat map.
Reduce by key.
Map you have seen.
Reduce.
And you worked with the filter also.
Filter.
And
Reduce by
Reduce by
Reduce
key.
by key.
Map values.
and one more transformation, map
values.
values. Okay, what are the actions you have seen?
Collect.
Collect
Sum.
Actions. Regularly you are looking at.
Collect.
And
Take.
just
Sum.
now you have applied some.
Take.
Take. Action.
Which way? Another?
Takes.
Take. Okay. Take is also action, correct. Okay, just to check first a number of samples you want to check, then take. All these are the different actions. And also here in this mini project, you have seen like how to apply custom functions on filter. And also you have seen how to apply custom functions on map transformation. Okay. So this is what learning summary of today. Before this, setting up PySpark in Colab.
Google Colab.
After that, 3 ways to create RDD. As part of this, you have seen sc.parallelize. This is not as part of the transformation. And also I have seen sc.textFile. I got final result over here. This result I want to write into output file. One more transformation I will introduce, one more action. What is the RDD name?
Sentiment occupancy.
Sentiment occupancy, right? That RDD dot save as text file and give the path. Content send. Now here sentiment is directory. I write this one. Directory. Within this partition files will be created. And also one more action. I have seen get RDD dot how to know number of partitions.
getNumPartitions.
Partitions. Whenever you apply this getNumPartitions, how many partitions you have in RDD that it will return. That is also action. I am running this now. Save as text file. Now look into this. There is sentiment. One folder is created. All of you observe this. Expand it. You will see your output in part-00, part-1. Part-000 means first partition. Part-001 means second partition. In the first partition, there is no data, but unnecessarily partition created. In the second partition, there is data. Positive 33, negative 66. All of you understood? Okay, but I want to write only one file, sir. I want to write 2 partitions because small result, right? Then you can control number of partitions. How to reduce number of partitions? To reduce number of partitions, here you have one more thing. sentiment underscore occupancy dot coalesce. Coalesce of 1. The coalesce function to reduce number of partitions. If you want to increase, there is another statement, that is a repartition. Later concepts we will see. Now let's say result is equal. Now check it, result dot get num partitions. How many partitions now?
1.
The sentiment occupancy have 2, but in the result, I have 1. Now if I write it, only one output file I will get. Now just check it, result dot save as text file. Content. Let's say sent result. Now this is a folder. Within the folder, partition file will be created. Now I am running this. Where is the sent result? Here sent result. Observe how many files, how many partition files now?
1.
Only one partition. This is the data. All of you clear?
Yes, sir.
And one more thing, if data is like this, next I want to load this result into some Azure SQL table. Or I want to load into some Oracle table or MySQL table. If data is in the tuple format, I cannot load them into. I cannot load this data into my target tables in the databases. I want this output should be as a CSV file. That means some comma separator fields. So that's why before writing the results, you need to perform some transformation. Just check. File. Okay. First check the data, result.collect. Positive, negative. This entire tuple I want to transform into single line. Okay. I'm going to perform some transformation here. Result is equal to, let's say result lines equal to input result dot map lambda x. Here x is a tuple. From this tuple, take the first word. How to take? X of C. Plus, after that I want comma. Plus, after that I want this number. X of 1.
1.
But what is the data type of x of 0? String. But x of 1? Integer, right?
Integer.
I'm converting that into
String.
string. Now check what is the value of result line. Dot collect. So positive 33 as a single line. Negative 66 as a single line. All of you understood? Now this data is ready to be written into output file. Then later you can export that into different databases. Okay, now let's do that one. Final step. Result lines dot. Sorry. How to write? Save as text. Content. Give any directory. Okay, let's say result lines equal. So this is directory name. Already we have single partition only, right? I'm going to run it. Now check this. What is the output result lines? This is the folder. A folder is created here. I have one partition file. Check the output now. Now this is exactly as.
Yes.
CSV file.
Now can I export this file into later into my own databases? I can.
Yes, sir.
So in this way, before writing into some output, you have to format the output into string lines. Got it? So this is one simple mini project with called as sentiment analysis. So I hope all of you understand what exactly the meaning of action and what exactly the meaning of transformation. And now save as text file is what, sir? Save as
Action.
text file is what?
Action.
Action. Save as text file. So this is what our learning summary today. So many things, just it will take minimum 2 days time to get a grip over these things. What are the things I explained here to digest all these things? Minimum 2 days continuously practice it. Okay.
Sir, any output should be string, sir.
Pardon?
Any output should be string, sir, at the end.
While writing into the disk, keep it everything
Only-
as. Okay.
Only string.
Yes. Learning summary.
Sir, tuples and key pairs both are same, sir.
Pardon?
Tuples and key pairs.
Tuples and
Key pairs. Key and value. Both are same, sir.
Don't say both are same. Tuple can be anything. A, comma, B, comma, C, comma, D. This is not a pair, right?
Yes.
Understand? This is a tuple, okay, but it's not a pair.
Inside the list we can.
But in our data, A, comma, 10. What is this? That is a tuple. Okay. First one is key. Second one is value. Okay. In the pair RDD. So for the pair, input to each element should be tuple point number 1. But value should that should contain only 2 values. Then only you can call it as pair.
Key pairs. Okay.
Understood?
Yes, sir.
Sir, after practicing for this for 2 days, sir, can we request for the practice session on Monday, sir?
Once again, please.
After doing all these things as a practice in 2 days, can we request for Monday as a practice session on this same, sir, project?
So please, instead of going for Monday because alternative days, I will again come back on Tuesday.
Okay.
Immediately, I will jump into next topic on the Tuesday.
Okay.
Tomorrow, Saturday, Sunday, Monday, I will share you this document. So please practice all the things. Including input files also, I will copy here.
But the practice sessions are with anybody else?
Practice session, you do it. Already code is with you. Data also I will do. I will send with you. Okay.
Okay.
So this is already the code is every code is here, including explanation what are the things I have typed. So please finish the practice session on Monday. So tomorrow, Saturday, Sunday, if you find free time tomorrow weekend, also do that one.
Okay.
Okay. So Monday, Tuesday, I want to go with a new example because practice session you do that.
I understand.
Because code is data also I am copying. I'm going to before sharing this data also I will copy.
Okay.
What are the data sets that I have used? Where is our collect? Before this I will copy. Already copied, I think. Data is already copied.
Yes.
Okay. But previous to previous employee file. This file I will copy. This file I will copy here. input file is emp1.txt. So no header in this file.
Okay.
So later in the data frames, if the file is having the header, how to deal that, we will discuss. No header. And below is the data. I will copy the data, just wait.
So somebody else is there, sir, when we are doing the practice session to be there on Monday, sir, is it possible from your
Monday?
Monday, if after we do the practice, sir, Saturday, Sunday, and Monday, if it is possible, well, we do it like I and anybody else is there. At that moment, is somebody else going to be there, sir, as a mentor?
Sir, it is a PySpark, sir. No Mamata, no Lakshmi, no Divya could not able to deal these things. Okay?
Okay.
Because a person who are capable of PySpark, they will not work as a mentor. They will work in real-time industries with high packages, right?
I know. I
So we cannot
understand.
engage such kind of things. Sir, already code is ready with you, sir. Just keep this code and do the practice.
So we'll do our best.
Okay, do the practice. Wow. So simply suppose in what way I am helping you here
Sir.
is it really necessary, sir, going this much of a biggest scenario?
No, it's not required again.
No. Just from my side, I am asking you, not your side. Is it really necessary?
No.
Why I am helping you by taking one real-time scenario and teaching you this much of time?
To understand.
Understand? You have to practice it.
Okay.
Got it? Simply reduce by key A comma B, one example, then reduce by key over. Take 10, 20, 30, apply a filter, okay, filter transformation over. Why I am including all these things? Because to make you powerize.
Yes, to better understand.
Okay, try to cooperate.
Yes, sir, please.
Okay, again, if I engage something means like the budget and all these things, timings, our duration, everything will not set out. Already I am taking alternative days. Because of alternative days only, today, approximately, I have taken more than 1.5 hour session.
Yes.
Okay?
Okay.
So again, I will meet you on Tuesday. So tomorrow you have time, day after tomorrow you have time, Monday you have time. Please do finish that practice.
Fine. Thank you.
Okay, please cooperate.
Yes.
Already file copied, sir.
Thank you very much.
Yeah, thank you. I will share this notes, but just wait. We are at almost climax. In the main notes only, I will copy this link, sir.
Sir,
1 minute, madam. 1 minute. Where is our main notes? Here I will keep it. Spark Colab is there, right?
Yes.
Here. Learning summary, because if I keep learning summary, the LMS support team will upload in the LMS. That's why for their purpose, I will copy
In the collab, it says.
first this link. The collab in the last week and that summary. Okay.
Thank you, sir.
Yes, sir. Thank you. We'll see you on Tuesdays. Meanwhile, please finish this practice. Now, madam, you are going to ask something, please.
sir, for if there are R1, R2, R3, for
Hmm.
R4, I can do the transformation only on R3, sir. I cannot do it on R2 or
Your
R1,
wish,
right?
your wish. If you say R4 equal to R1 dot, what
Sir,
happens?
but when it comes to
There is no
R3,
but,
R2 will
madam.
be
R1, R2, R3 you said. R4 equal to R1 dot you are saying. For R4, what is the input? R4. For R4 input is R1. Understand? You are saying like this. 1 minute. My statement. Let's see that will start at 2 minutes. One minute, stay on the line.
Yes, sir.
Okay. Whiteboard is not working. Start. Let's say the flow is like this.